Okay guys, I wanted to hop on real quick and make a video for you to show you how to graph an inequality. So an inequality has an inequality symbol instead of an equal sign, but we're basically graphing them just like we would graph an equation, right? So think of y equals mx plus b. When we graph that, we first find the y-intercept, right? And we plot that on our graph, and then we move according to our slope. So in this case, we'd put a dot on -2, and then we would go up 2 to the right 3, right? And we would draw a line and we'd be done if this was an equation. So it's a little different with an inequality. The line's gonna look similar, but we're gonna actually be shading some of our graph, right? So when we look at our graph, y represents the area that we're shading. So when we're trying to figure out, are we going to shade above our line or below our line? Well, y is the shaded part. So is the shaded part going to be above our line or is it going to be below our line? In this case, it's bigger than our line. This part right here represents the line that we're drawing. Y is the shaded part. So our shaded part is going to be bigger than our line. It's going to be up above our line. Okay, and then when we look at our inequality symbol, that's going to determine whether our line itself is a solid line, like normal, or a dotted line, right? So let's just start graphing this, and I'll show you what I mean. Let me grab a red pen. Okay, so we're going to start off by plotting -2 on the y-axis. So here's our graph. On the y-axis, I'm going to go down, start at 0, 0, and go down to -2 and put a dot, okay? From that dot, I move according to my slope, which is +2/3. So I'm going to go up 2, right 3, starting here. Up 1, 2, over 1, 2, 3, and I put another dot. And I can do it again. Up 2, over 1, 2, 3, put another dot. Okay, and then once I have that, now I have enough to sketch my line. But when I sketch my line, I gotta know, is it gonna be a solid line or a dotted line? So I'm looking at, sorry, my son's knocking on the door. So I look at my symbol, and if it does not have the line underneath here, right? If y can't be equal to my line, if the shaded part cannot include my line, then I'm gonna leave the line dotted. If this has a line underneath it, it means that the shaded part could be equal to my line. So it would include my line, and in that case, I would make my line a solid line. But when there's no line under here, my graphed line is going to be dotted. So I'm going to connect these, and I'm just going to kind of sketch like a dotted line through them. Just like that, dotted line, right? So here's my line. Looks just like it would if it had an equal sign here, right? It's the same line, but we've made it dotted, and now we have to shade. This is the important part that a lot of people forget. All right, so remember I said y is the shaded part, and the shaded part is greater than my line. So I'm going to shade everything on my graph, not just a little portion of my graph, everything on my graph above the line. You gotta shade everything. So if you made your graph really big, then you gotta shade really big. If you made your graph small, then you don't have to shade as much, right? But you have to shade everything on your graph above this dotted line. I should have extended the dotted line out more. So don't just do a little bit of shading right here. You have to fill up your graph. Okay, let's do another example to get used to this shading. So here I have y is less than or equal to -4/3 x minus 4. So I'm going to sketch my line just like I would an equation. Start off with -4. I'm doing it in blue. -4 on the y-axis. Here's my y-axis. Start at 0, 0. I'm going to go down 1, 2, 3, 4. And then from there, I move according to my slope, which is -4/3. So I'm going to go down 4, 1, 2, 3, 4, over 1, 2, 3. Well, I don't have 3 spots here, so I'm going to actually go backwards. Instead of down, over, I'm going to go up, back, right? It's the same thing. So up 1, 2, 3, 4, backwards 1, 2, 3. And now if I moved to the right, I'd go down 4, over 3, and I'd get to this, okay? So I have my enough dots to draw my line. I'm going to sketch my line with my straight edge. My inequality symbol does have a line underneath, so my line on my graph is going to be solid. Oh, my pen got hung up in this, sorry. Okay, so make sure it extends through your entire graph. Don't just draw a little gimpy line right here and leave all the rest of it undone. Extend through your whole graph. And then now we have to shade. We're not done, we have to shade. So here, remember y is the shaded part. The shaded part is less than my line. It's going to be underneath my line, right? So think about it. Some people still get confused because it looks left to right, and they're like, well, which one's less, which is more? Well, think about if you shaded this way, you're kind of going up, right? If you shade this way, you're going down. So we want to shade less than our line. So we're going to shade everything in my graph on this side of the line. I'm going to fill up my entire graph, right? Some people just want to shade just a little bit right here. No, you got to shade the whole thing, all of your graph. Because really, the shaded region is infinite. It keeps extending. We're just not going to shade our whole paper, so we stop at the edges of our graph. But it's going to look like that. Okay, so our first graph was a kind of a bad drawing, but a dotted line, and it was shaded above because y is greater than the line. This one, y is less than or equal to the line. So I've got my line. It's solid now, and I shaded below it. Okay, so that's how we graph an inequality. The line itself looks just like an equation, but it's either going to be solid or dotted, and then you have to shade above or below. And this represents, the shaded part represents all of the coordinates or all of the points that could be solutions to my equation. So I could pick the point in the shaded region that's like at negative 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, negative 5, 5. Negative 5, right? I could plug that in here. If I plugged a negative 5 in here, negative 4 times negative 5 is 20. 20 divided by 3, 21 divided by 3 is 7. So let's just kind of guesstimate, round it up to 7. 7 minus 4 is 3, right? That would be a positive 3. And then my other negative 5 would go here. Because remember, it was negative 5, negative 5. Is negative 5 less than or equal to 3? Yep, that's true. So all the points in the shaded area and on the line would be solutions to this inequality. Up here, all the points in the shaded area but not on the line would solve this inequality. None of the points on a dotted line are solutions, only everything shaded above or below it, right? In this case, shaded above it. So dotted lines are not part of the solution. Solid lines are part of the solution. All right, and then the last kind is confuses people because they are horizontal and vertical lines. How do I shade? How do I know which way is greater or less than, right? So if I graphed y is less than 2, on my y-axis, whenever I have just a y, that's going to be a horizontal line. On my y-axis, I'm going to start at 0, 0 and go up to 2 and put a dot. Okay, and then normally I would just draw a horizontal line through there, right? So I'm going to do that, but I have to know if it's dotted or solid. In this case, it's going to be dotted, which means none of the points on this line will solve this inequality. None of that would be true. Let's just pick a point. Let's say over 1 up 2, 1 comma 2. When x is 1, y is 2. Well, there is no x, right? But we could put a 2 in for y, but then would 2 be less than 2? No, 2 is equal to 2, but it doesn't say it can be equal. So that wouldn't be a solution, right? So nothing on this line can be a solution. That's why it's dotted. But the shaded region is less than 2. It's everything below that. Anything in this shaded region is a solution. Any of these points is a solution to that inequality. So basically, it doesn't matter what your x value is as long as your y value matches, right? There is no x variable here, so the x variables here don't matter, but the y variables do, okay? And then if I had a vertical line, like, for instance, x is greater than or equal to negative 1, on my x-axis, I would find negative 1, which is here, and then I would draw a vertical line through it, and I'm going to do that. Is my line going to be dotted or solid? Well, it's got this little line underneath it, so that means I'm going to sketch a solid line, right? And then how do I know which direction to shade? Do I shade to the left or to the right? Well, think about it. X is bigger than or equal to negative 1. So which direction are all the numbers bigger than 1 on the x-axis? Well, these are all negative numbers, but these numbers are bigger than negative 1, right? So I'm going to shade everything to the right of my line. So in this case, all of the points in the shaded area and on this line are solutions to this inequality. See what I mean? So hopefully that's making sense to you guys. These are what your inequality graphs will look like. There is shading, okay? The shaded part is y, or whatever variable you have here. The line itself is this, right? We know where this line is because of this. This is our line, this is our shaded part, and then the symbol here just tells us if our line is solid or dotted. That's it. So let me know if you have questions on that.